Okay, so in this video I want to discuss how can we set up our deployment infrastructure across multiple clouds, so it's gonna be still very reliable but cloud agnostic. So the idea is that we have the core services deployed within our cloud, and the core services are the instances of something that we manage. So let's say this is the AWS, and then within AWS we have our Kubernetes cluster. So this Kubernetes cluster includes the deployments of our core services like MDS, DRS, so on and so forth. These are our services. We are responsible for deploying them. However, there are certain parts of infrastructure that are still managed by AWS. So for instance, we're using managed airflow. It is deployed outside of our cluster. It lives within AWS. Also, each of the services, most of the services I would say, has the RDS Aurora database instance. So we have a couple of S3 buckets that we're using in AWS. Also, we have the SQSQ. So our services are using these dependencies like MWA uses. These services are all interconnected. So now what makes the big challenge here is that if we consider this part of infrastructure, we can only guarantee that the Kubernetes part, which is actually this square, would be cloud agnostic. So we can deploy this part of infrastructure to any cloud without any friction. But it means that these services that outside of the Kubernetes square, they need to be deployed separately to the infrastructure when it comes to different clouds. So let's consider the extreme example of how to make our infrastructure completely cloud agnostic. So with this approach, if we follow this approach, this is the first example. This is the approach where, let's name it, this is the approach with cloud agnostic resources. And then let's go back and say, create similar approach that we'll use is going to be another extreme. So it's maximum cloud agnostic resources. Let's just move it over here. So in that case, what we're going to do, we will fit everything into the KIDE. We have MWA. It's going to be called airflow. Okay, and here will be ElasticMQ. So here is a complete another extreme example of cloud agnostic infrastructure. So in that case, we're putting everything into KIDE. So there are literally no resources that exist in AWS or any cloud provider that we deploy to without. And let's compare these two alternatives. So the first alternative, the biggest benefit of this alternative, that we have a lot of our services managed. So we don't need to spend time and to involve a lot of efforts to maintain them. This involves like RDS Aurora, Apache Airflow, S3 buckets, and SQSQs. Now let's go to this example where we have everything in KIDE. So now it means that we are responsible for all the deployments for each of these services. And it introduces us a couple of maintenance overhead, because now we need to take care about PostgreSQL, Airflow, and so on and so forth. However, the biggest benefit of this approach is that we can forget about, I would say almost forget about, cloud platform integration, as far as this solution could be deployed to anything, even to the bare metal. So this is the most versatile. So in our use case right now, we have an AWS deployment, and we have two potential clients who have data residency restrictions. And they data residency restrictions are mostly connected to either a specific region of AWS or a specific cloud provider. In our case, it's Google Cloud Platform. There are also discussions about government clouds that are also AWS. So literally, what do we want to support? We just want to support AWS and Google Cloud Platform at the moment. There are two platforms that we need to support. So hopefully, if we know that our priority right now is support these two platforms, and we are not yet a giant company that has big staffing that can afford maintaining all of the infrastructure managed by themselves, we should aim for the balanced solution here. The disadvantage of this approach is that we need to invest a lot of initial effort in our infrastructure setup. As far as if we go to Google Cloud Platform, we need to find the replacement for each of these services that are located outside of the Kubernetes. like RDS Aurora, Airflow, S3 buckets, and SQS. So let's go and analyze step by step which maintenance requires for each, how much maintenance each of these dependency requires. So eventually, in case we have the Azure client, then yeah, we will need to also find the similar stuff in Azure. However, at the moment, this is what we have GCP AWS. Let's consider so RDS Aurora managed, autoscalable, but expensive. However, with RDS Aurora, we can just completely forgot about our databases. We have set up them once and we know that they are autoscalable. So whenever we get traffic spike, anything like that, the database resources will be automatically adjusted to our needs. Also, the storage is autoscalable. So whenever, let's say we claimed like 100 gigabytes of database storage, and then our database is 90% full, so AWS will increase our storage without us even knowing. So we just don't need to care about everything. Also, it provides all. So these are the main benefits of Aurora. So it's managed. It means that all of the version upgrades, anything like that, AWS takes care about it. Well, of course, we need to take care about the major version upgrade, but at least the minor version upgrade is handled by AWS, which is a significant benefit for us. Scalable resources means that we shouldn't be worried about resources, overutilization, traffic spikes, anything like that, because AWS will scale the database according to the requested resources capacity. Autoscalable storage, AWS will scale the storage accordingly, depends on how much it utilized. Automated backup mechanism. So it's a complete solution. It's expensive, but we know what we are paying for. In our low scale, it's probably going to be more expensive for us to hire additional team members to manage this database. So this solution is the most appropriate for us. Now let's consider another alternative. And this alternative will be the badass deployment of PostgreSQL. So we're managing. It has autoscalable resources, that's correct. It has automated backup mechanism. So the downsides of the Kubernetes deployment of PostgreSQL is that we need to manage version upgrades ourselves. That provides a bit of an, I wouldn't say that it's a huge overhead, just maybe once at 6 months, once in a year, we need to make it update. It's a tiny overhead. It still has the automated backup mechanism. There are a whole bunch of open source solutions that could be easily set up for this database to have an automated backup mechanism. So we have pretty much the same that we have from the RDS Aurora. However, we can't have autoscalable storage here. And this is because of the nature how the Kubernetes works in cloud platforms. So when we're using something called persistent value claim, and persistent value claim, it's just a request to the cloud provider to give us the persistent value. And this request is specifying how much storage do we want. Let's say we requesting 100 gigabytes of data for PostgreSQL and a persistent value claim. So in that case, our database will have 100 gigabytes of data. And unfortunately, Kubernetes doesn't allow us to automatically request more storage. So we need to update the Kubernetes configuration every time we want to increase storage. Of course, we can implement the mechanism that will monitor the storage utilization versus available storage and then update the Kubernetes configuration of the persistent volume claim accordingly. However, it will introduce us another issue as far as all of our configuration will be the management in version control and configuration update will happen through the Git flow process. It's going to be another challenge to figure out how the automated storage scalability should fit under the Git flow solution. So with the case of as deployment of PostgreSQL, we would need to either be reactive on the storage utilization monitoring alerts. So whenever we get monitoring alert, the database storage is more than 80% full, or we'll need to go and create another MR that will upgrade the storage, or create somehow of a mechanism of automated storage scalability that still would be managed by us in order to support it. So I would say it's a plenty of overhead for the PostgreSQL database to be deployed within the cluster just for having the flexibility of cloud agnostic implementation, considering that right now our cloud agnostic solution should only support 2 cloud providers, AWS and Google Cloud Platform. So let's consider another set of the S3 buckets. And I don't know which advantages of the S3 buckets I can specify. I will just specify serverless. And that's gonna be enough, because it means that we don't care about anything, neither about storage, nor about managing it, anything like that. Nothing. So the alternative of the S3 bucket within the Kubernetes will be something called, what is the name of it? It's MinIO. So MinIO, it's the S3 compatible self-hosted replacement of the S3 bucket. So what are the benefits of MinIO? It's compatible with S3 SDK. So it means that there shouldn't be any application level changes if we introduce MinIO. Another benefit we have is auto-scalable. Yeah, so we shouldn't be worrying about resources, overutilization, anything like that, because Kubernetes will allow us flexibly scale this solution. However, we are facing here the same problem that we have with Postgres, and this problem about the storage. So the storage isn't auto-scalable, and it means that we will need all this overhead of managing storage ourselves. Whenever the storage gets close to full utilization, we need to figure out a way how we scale it, either manually or using automated flow. And again, it's a big maintenance overhead, considering that we only need to support 2 platforms. So I'm not thinking if it's worth considering MinIO. So let's consider the alternatives of these services in GCP. So yeah, I will do it like this. I will create here the column that called AWS. These are as, and let's go to the GCP. And the GCP we can use something they called, it's called Cloud Scale Serverless. I would even just copy paste the benefits from the AWS because they are the same. So, and same applies to the bucket, cloud storage bucket connection using AWS SDK. So we don't need to change any of our existing code. All we need to do is just supply different serverless, different S3 endpoint and different credentials, and our application would just use the S3 SDK to communicate with cloud storage bucket. So let's step further. Let's go to the SQSQ. So with SQSQ in the Google Cloud Platform, we can alternative the calls pops up, and in Kubernetes, really, we want to deploy everything we want. I really like the NetsQ messaging broker. However, in this particular example, I will focus on ElasticMQ. Why ElasticMQ here? Because ElasticMQ is really trivial. It's really lightweight, straightforward. It doesn't have any rich amount of configurations in comparing to Redis or RabbitMQ. However, the biggest benefit of ElasticMQ that it is the self-hosted replacement of the SQSQ. So again, it means that we don't need any application level changes, right? So for SQSQ, I would say that it's serverless. This one I will type to scalable, compatible with S3 SDK. There is no storage in the queue, so we don't have any overhead here. And let me also draw. Okay, so we have it like this. So let's consider 2 alternatives. So the first way is we do as we did with those services. Considering that we want to go with as many maintenance responsibility as possible, we decide to use the cloud native solution, SQSQ. So when we go to the Google Cloud Platform, the cloud native solution will be GCP pops up. It provides all the same benefits as SQSQ. There is no problem with that. However, there is a big bottleneck here, and the bottleneck here is that PubSub SDK is not compatible with SQSQ. So in order to make our infrastructure to be deployed to both AWS and GCP, we need to maintain 2 different type of queue brokers connection our application level. And I think it might be overhead for the application support. In ideal world, the application code should not be dependent on the infrastructure in any case. When in case of database, we're still using the same Postgres connection to any of these solutions. In case of SQSQ, our existing application uses the S3 SDK, and it means that we can only consider these solutions. But unfortunately, with SQSQ, we can support GCP So the only alternative we have is have a self-hosted Elastic MQ. And let's consider overhead that we get from self-hosted Elastic MQ. So it's fully compatible with SQS. We don't need to change application code. It's fully auto-scalable. So as far as we don't care about SQS queue because AWS manages it. In the same way, we won't need to care about Elastic MQ because it will be auto-scaled by Kubernetes. It's lightweight, so we shouldn't experience any issues with that. The only overhead that we might have using ElasticMQ is that we have just another log stream to monitor. So we'll have ElasticMQ self-hosted, and we need to set up the ElasticMQ logs monitoring, service monitoring, and in case some crashes happen here, we need to jump in and investigate. This is the only overhead. However, I'm not sure how relevant this would be for us because ElasticMQ is so lightweight and so single purpose that just transferring simple messages among different services within cluster should not introduce us with any challenges here. So for that reason, we should be able to easily support it. Now let's get down to our next dependency, and this one is managed Apache Airflow. Here you go. So in Kite, and here we can just specify that it is managed. I don't know what managed will mean for us in this case. So GCP Cloud Composer is an alternative of managed Apache Airflow in Google Cloud Platform. So Google Cloud Composer is also managed as they claim, and it's completely compatible. It provides the same capabilities as managed Apache Airflow provides for us. And there is another alternative, is to self-host Apache Airflow within the Kubernetes. What are the differences between those? So basically, Google Cloud Platform, Cloud Composer, Apache Airflow are compatible with each other. Of course, they require completely different infrastructure setup, and there might be some differences in the compatibility as well. Some minor differences that we might experience later down the line. Yeah, but at least from the first glance, they're fully compatible, so there shouldn't be any issues with them. And then the approach in between is self-hosted Apache Airflow. So let's compare different benefits. So all of the three solutions are auto-scalable. Apache Airflow auto-scalable, GCP Composer auto-scalable, and Kite solution is also adjusted in Kubernetes as auto-scalable. All these three solutions requires manual updating. So either we're using Apache Airflow in AWS. If new version of Airflow arises, we need to manually update it. Same for Composer, same for self-hosted. Then the database within the Airflow. So it also includes implicit serverless SQS queue under the hood, how the Airflow works. Then same happens in Google Cloud Composer. They also include database and probably pops up queue under the hood. But when it comes to Kubernetes, we set up the infrastructure and we're deciding which database and queue we could use. So in our case, we can just simply spin up a database instance on the cloud, either GCP or AWS, and connect Apache Airflow to the AWS instance. Thus, we have completely serverless managed AWS instance while still having the flexibility of self-hosted Apache Airflow. So the same applies to the queue broker. We can connect Apache Airflow to any queue broker, and if we decide to use ElasticMQ, it means that we can just use ElasticMQ in all these cases and connect Airflow to ElasticMQ, which is really lightweight and low maintenance service, and we're achieving pretty much the same what we have in serverless solutions. So, and all of these services requires monitoring. So we're still monitoring logs of each service, like web server, task service, anything like that. Any of these services requires the monitoring, either in GCP or Airflow or in custom deployments. So this choice might be a bit tricky because each of these services has their own pros and cons. If we consider Apache Airflow, the managed service, the disadvantage of managed service is that it's harder to deploy it locally or harder to have multiple instances of this service to perform testing because it's very expensive. While the managed service is less expensive, it requires some infrastructure setup at the beginning connecting to the existing cloud resources. However, on the other side of the coin, if we're considering the cloud agnostic approach, it will support both GCP and AWS. We would need to maintain two type of solution like that of the managed solution. So this is the good point for consideration. However, the there might be the third approach. The third solution is, so the third party serverless Airflow, we might benefit about it a lot as far as it's a completely serverless. So we don't need to monitor any logs. We don't need to manage anything. We just using it. However, it's expensive. So if we compare it with the managed Apache Airflow and Google Composer that are still expensive, the third-party solution is even more expensive. Also, there might be challenges when it comes to local deployment, local testing with the managed solution like that. And depending on how broad our data residency restrictions will go, there might be some services, some DAG processing operations that will be subject of data residency restriction. And it means that we can longer use the third-party serverless solution. And this is a huge bottleneck for us making this consideration right now. So taking into account all of these pros and cons, in my opinion, the most reliable approach here would go with self-hosted solution, because it will require the same maintenance as the managed solution right now. So the database will still be serverless. The queue, we can almost say the queue is serverless, because I'll say it managed, because it's so lightweight and so straightforward that there is real low maintenance with that. Considering that we're gonna be using the Fargate provider for hosting our Kubernetes cluster, and also we're gonna be using the GCP Autopilot Kubernetes cluster, we can almost say that this is serverless. And managing the web server, task processor, and all of these other Airflow infrastructure parts would not be more complicating than using managed Apache Airflow solution, because we're still upgrading versions here. We will need to upgrade them here as well. We're still monitoring logs in managed solutions, and we still will need monitor logs in our self-hosted solution. Our managed solution is auto scalable, the same auto scalability we will have in self-hosted solutions. So I don't see any reasons of worrying about maintenance overhead with the self-hosted Apache Airflow. So the last one will be probably the SageMaker. So the SageMaker provides us with the ability to give our clients Jupyter Notebook interface. We're using SageMaker because this is the managed AWS solution. However, the biggest limitation of this solution that it's not scalable, because we need to deploy this solution per client. So it means every client that want to utilize the ability of Jupyter Notebook to query their Robolog needs to reach out to us, asking so we can spin up AWS infrastructure in our AWS account for them. That is not acceptable in the long term. So the SageMaker service, it is a big subject for consideration for a lot of time, and I think there shouldn't be any doubt for us to switching SageMaker for something else. And in this case, it definitely won't be the cloud native solution. And one of alternatives is using Jupyter Hub. While I can't provide the specific benefits of the Jupyter Hub because I've never experienced working with them, I know that it supports multi-tenant deployment. It means that we can only have one deployment of our Jupyter Hub infrastructure and provide the interface to all of our customers with that one deployment. So it means that we can have a scalable solution, so each of our clients can use a Jupyter Notebook to query their Robologs without any problems. Alternatively, we could explore any third-party solutions there, but I'm not sure how relevant it would be for us. So let's have the self-hosted maintenance database. And I think it's pretty high because it requires significant investment in infrastructure setup to have it reasonably automated, and also it would require the storage management. I would say it also the same as cloud native, because we will still have the same level of automated Airflow management and serverless resources as we would have than cloud native. Why? Because even if we would need to keep an eye on the Jupyter Hub Kubernetes deployment logs from time to time and monitor the alerts, we would not need to deploy a separate set of SageMaker resources per client request. These would be automated, and I think this is dramatic benefit here. So considering the management that requires of the self-hosted resource, that might be pretty much the same, but considering the overhead on the regularly deploying, spinning up different SageMakers is definitely low overhead. And then let's consider the different application level changes that are required. So with AWS Aurora, we wouldn't need any changes, no matter which solution we use. AWS Aurora together with Cloud SQL, or we use PostgreSQL, we don't need application level changes at all. We S3 bucket, I would say non current cloud require. So when it comes to GCP and AWS, no matter which approach we'll go, either we use cloud specific AWS and GCP storage bucket deployment, or we will use the mini self-managed deployment. We won't need any application changes. However, if eventually we will have the request from client to use DigitalOcean or Azure, in that case, it would require us to perform the application level changes if we use the cloud native approach. So the SQSQ, none for AWS and self-hosted. So if you go with self-hosted, then no changes required. If we still want to maintain same AWS, no changes required. However, if we would need to deploy to GCP and we want to use PubSub, it's a bit of an overhead because we'll need to maintain both GCP and GCP PubSub in AWS SQS support in our application. So manage Apache Airflow. I'm not sure about this one. I think no matter which approach we'll choose, we'll definitely some changes needs to be required. Either if you choose to keep AWS managed Apache Airflow only, and even for Google Cloud Platform deployment referred to AWS Apache Airflow, we still need application level changes. For if we want to use the self-hosted Apache Airflow, we still need application level changes to it. The same for this one. I think some changes might be required. The SageMaker, I think also some changes might be required because I'm not sure how the application level of the SageMaker is configured. So that's pretty much it. This is the overview of different dependencies that are cloud native right now and different alternatives of how we can swap those dependencies or extend it to different clouds to support multi-cloud deployment, and just pros and cons comparison of those dependencies that can get us balanced between almost complete cloud native approach that will have lower efforts to maintain but still might have big efforts to initiate it. And considering these pros and cons, we can find the balanced solution that will let us actually to balance between the maintainability overhead, initial infrastructure configuration overhead, and the other benefits that we might receive from this approach. And let me basically extend it. This table is the final column, and I call it recommendation. So when it comes to the databases, I would recommend go with cloud native approach, considering the pros and cons of both solution. Same applies to the S3 bucket. So the main idea go with cloud native approach here is that no matter where we host our Postgres, we don't need any application level changes. However, we can choose to host it in an effective way, so we have less overhead with that. When it comes to S3 bucket, we might have challenges on application level changes if we go cloud native, by considering that our requirement scope in the moment consists of just AWS and GCP, there shouldn't be a problem. So when it comes to SQSQ, in that case, I would recommend to go with self-hosted approach, because first of all, self-hosted approach would not require us application level changes. And even if we decide eventually to go with some kind of a better, more advanced queue broker, and it would require application changes, it'd still be easier for us to do if we choose self-hosted approach. And if we compare the self-hosted approach with the cloud native approach in terms of maintenance overhead, so we have pretty much the same maintenance overhead as we have in cloud native approach. So the managed Apache Airflow, I also recommend to go with self-hosted. As far as the managed overhead will be the same, and the initial infrastructure setup will be significantly easier. And also we need to have less application level configurations when it comes to the Apache Airflow, because if you have one solution that is self-hosted, we only need one set of application level configuration that will initiate this code. The same applies to basically to the SQSQ. So if we go with cloud native approach here, we would need to maintain two type of SQSQ SDK to support both AWS and GCP. And here, if you also choose any kind of managed solutions like that, and in case you want to use per cloud deployment, we might have the first challenges. Each of the Airflow hosted deployment require different SDK to communicate, and also considering maybe irrelevant long-term scenario when we will need to host to any kind of Azure or DigitalOcean or any platform like that doesn't support manage a Airflow solution, we will come back to this decision. And when it comes to SageMaker, in this case, I would recommend to find something self-hosted, because obviously the self-hosted overhead is gonna be even lower than managed for us right now, considering that we're using the Jupyter notebooks externally. So the SageMaker purpose is for us as internal team to use the Jupyter notebook to perform some data visualizations for our external team, and it's not created to be like the multi-tenant interface for our users, while Jupyter Hub is created to be multi-tenant interface for our users. That's why I'm advising to use the self-hosted Jupyter Hub. I might change my mind eventually if we found that self-hosting Jupyter Hub is a bit more hassle, so we might be able to search for some third-party serverless solution for the Jupyter Hub. But at the moment, I would recommend to go with self-hosted solution.